Hi everyone, and welcome to our talk, AfriVEC, what embedding models for African languages. In this paper, we focus mainly on Fon and on Nobiin. I am Bonaventure, so I will be presenting this work on behalf of my colleague Mohammed, who wasn't able to make it today. So there is no surprise, no doubt, no surprise, no doubt that word embedding models have played very essential and important key roles into the performances of NLP algorithms, neural network models being designed the way, word embeddings being designed in such a way in the context, in the idea of giving much more meaningful and contextualized representations of words, entities in the context. So true that we have word embeddings models, pre-trained word embedding models for high resource language, be like French, English, and we can of course fine tune them on on specific downstream tasks involving African languages. But with the recent rising efforts of building data sets for African languages, of creating neural machine translation for African languages, of building name entity recognition for African language, all of these tasks in which intervene the use of word embedding models, we believe that it should be much more better, it could be much more better, much more interesting to have proper word embeddings built rooted on those languages, African languages. And the other aspect, the other reason is as word embeddings are meant to capture representations and give meaningful information about the words and the entities. It also captures the style, the lifestyle, I would say, the daily life, the culture, and it has been shown in many papers. So that's meaning the motivations of our paper, of our work, to create word embedding models proper to African languages that will be able to efficiently represent and capture uh, the meaning of our language entities or attributes, be it like names, cities, maybe day of the week, or name of people, and so on and so on. And of course, we want this not to be the only one initiative because there are very few so far. We want to create that interest in African NLP researchers, especially in more broadly NLP researchers in general, to move the center of attention of from English to other low resource languages, including Africans. So in this talk, I will briefly describe, sorry, the Fon and Nobiin, giving just main few key points about the linguistic aspect, the language, alphabet, and everything. I will give an overview of the word embedding models and Poincaré embeddings. I'll focus then on the data collection experiment result that we did. And funny enough, we saw very interesting aspect of, like I was saying, of those word embedding models that was representing very the uh, the cultural and the lifestyle of people living in those regions. So we try, attempt to give some more information about them, linguistic and social interpretation that we believe that could very be pathway to further exploration and to improve the result we have in this paper. So Fon is mainly spoken in Benin, but also in Togo and Nigeria. Spoken, it has 10 vowels and 22 consonants. It's mainly based on the Latin alphabet, but has more characters, like more accentuated characters. It has much more it had more D graphs, like two words together representing one, like GW together, GB together, like is which is pronounced as B. Yeah, so those kind of words. Fon also has 50 different dialects and is morphologically very rich. Nobiin on inside is spoken only by 1 million people. We can already see the balance between those two languages on northern of Sudan and southern of Egypt, mainly based on the Greek alphabet and contains 10 vowels, 18 consonants, and two dialects that highly represent the culture on the different parts of Sudan and of possibly Egypt, where the language is spoken and widely used. So here I will just give it an overview about the different kind of models, word embedding model, word to vec models that we have. We have three main different word embedding models whose mathematics are well known and which also we try to revisit in our paper that you can find online. The one word or symbol defined as continuous bag of words model or architecture. In that, we are trying just to do a one-to-one prediction. So you have one word, one context word, and then we want to predict another word. We have the multi-word context, which is similar to symbol, but then focus on the relationship between a single word and other words on the entire corpus. So it might be all the words or the remaining words, or it might be many other words, target words that we want. The last one is the other one I would say is the skipgram, which is the opposite. So I just say that we have one context vector and then we want many targets to see how that one context, the word context, is related to other words. In the skipgram concept is the opposite, as the author have described in the picture. We have instead many different context words that we now want aligned together jointly and with the target to be predicted as only one word. So it's like a kind of schema of many to one. Poincaré embedding has been introduced in 2017. I think it has not really been highly used, and is just making use of the joint combination of hyperbolic geometry and the Poincaré ball properties. In the papers, in the original papers, the authors from Facebook, I think, mentioned that the combining both those two aspects really help to get sufficiently the similarities between two different Poincaré word embeddings and the hierarchy, like the words that derive from them. Like we can look at it as a tree that grows with every new child. Yeah, you can see. We can also see on the screen the different formula that defines the length or the diameter of the cycle. This is just in a two-dimensional space, right? But because in three-dimensional space, we're already talking about sphere and everything. So it goes much more abstract when the size of the dimension increase. But there's also the definition of the Poincaré ball in the dimension D, size dimension D, and the formula that helps us to compute the distance between two different Poincaré word embedding models. Next, I will talk about what to vec. Firstly, about the data collection. Upon using the data set, the FFR data set that I worked on with my colleague Chris Emezuye and two of the linguistic students, Ricardo and Fabroni, I have extracted. I chose to focus on the family domain and extracted were sentences where I had words like dad, mom, sister, brother, daughter. On Mohammed's side, I mean, for Nobiin, we just managed to find very few sentences, like 40, due to the very big scarcity of data and previous NLP, neural machine translation name entity recognition that have not really been done in Nobiin. So this work is actually the first of his genre. So we managed only to find 40 sentences, but those 40 sentences are very highly representative of the culture. So we could see, for instance, words that mean sun, moon, and stars clustering together. You can find out all those details in on our paper. I cannot really, unfortunately, describe it as Mohammed is not here with me, but I can share some result about the form where we can see, for instance, Yonu, which means uh, uh, Nyon means, or let me say, girl or woman, and is a little bit close to Fufu, which means big brother, and close to To, which means father. If we come a little bit here, we can see words like no, closer To, sorry, which means Norvegi mother and Torvegi father. Yeah, so we already just using those few sentences, we show that um, those word embeddings, of course, they are the architectures. Using the architectures, we are already able to build models on them, and those models together uh, already are able to to extract and represent meaningful similarities between them. Here we have the table with that shares was similarity on form using the Fon work to vec. We can see that non-V, which means sister or brother, has been the most similar word is dada, which means big sisters. The second most common word is most similar word I want to say is fufu, which means big sister. We can have, for instance, non-V plus suno, like um, brother. Okay, non-V is actually either brother or sister. But then when we add Novi plus Suno, Suno actually gives to Novi the male character, the character of it precise the gender, and we can see that it predicted wife. So Thor means father chief, which means mind. And we can see that together it's most likely similar to no and many others. So the last one is, for instance, no and to, like those two words together gave much more similarities to the words education. So yeah, in our society, having mothers and fathers together is very essential for education of the people of the son, daughters, and everything. So for the Poincaré board embeddings, we also try to get more data through crowdsourcing, Google survey, Google Forms that we shared across internet, Facebook, LinkedIn, and Twitter. Yeah, and those other social networks, also with our friends, WhatsApp that we could use. We gathered for fun in general 642 data samples that we split it into train tests and validation, of course following the hyperless format, which is basically we have the words or the entity and we have the relationship, his tag. So maybe like let me say, for instance, just an example, Bonaventure tag with, for instance, name of boy, something like that. Yeah, so we did the same for Nobiin, but we had fewer data entries. So for train the models, we use many dimension size and many constant of curvature for both Nobiin and for both Fon. Then we evaluated the result by computing the capacity of reconstruction, which is the capacity of the observed data to reconstruct from the embedding. That's how the author described it. The link prediction that tests the general performance of the model. So the reconstruction, the lower, the better, I think. Yeah. And then after we perform a kind of predictions on words or on entities names, mainly using those word embeddings. So here we have the graph of Fon Poincaré hierarchy graph of Fon Poincaré model and Nobiin Poincaré model. We can see that we have, I mean, the subclasses are definitely away from each other, are very distant. So here we have girl names, we have boy name. Here we have mixed name. So there are other attributes here, like cities, day of the week, but they are clustered together. The one that have much more representation are those three ones. And we can see that their names, there is a link between mixed name and boy name, saying that, of course, in mixed name, there's possibility for to have names that both belong to, can be attributed, sorry, to both men and women, of boy and girl, and same thing for the boy side. But we have one link, like we have this link we can see here that goes from boy name, and that goes into girl name, the girl set, and this is also a misclassification. For Nobiin, we don't have that problem because everything is pretty much perfectly classified, but we have done it on a very small data set, and this needs to be conducted again on a higher data set to very confirm the result. So as I was saying, here we have the reconstruction, the mean rank, and the mean average precision. So the mean rank, the lower, I made a mistake here, sorry, the mean rank, the lower it is, the better the model is. And MAP, like mean average precision, the higher it is, the better. So we can see, for instance, for Fon, that the bigger the dimension is, the better gets the models in his capacity to reconstruct himself from the observed data and to perform better. We can also see that is the same for Nobiin, although we have already achieved the highest result already with five with a dimension space of 5. Next, we also did some classifications mainly, and we can see that for Fon we had an overall result of 49 of precision accuracy, and for Nobiin we have 50. However, we can see that words, I mean, girl names are very low classified. On like here 28 and here 14. So then we try to see, okay, what if we exchange? What if we transfer? So we kept the models as they are right now, like Fon trained solely on Fon dataset and Nobiin trained solely on Igbo dataset, on Nobiin trained solely on Nobiin dataset, and we try to use the model to do the prediction on the other dataset, performing some kind of transfer learning. And we can see that on the Nobiin data set, the Fon model has performed very well. Somehow, if we come back, we can see that it was only able to predict to have a recall of 63, so not so much high accuracy. But here, it was able to predict much more better. Same thing for Nobiin on the Nobiin model on the Fon dataset, but unfortunately, while the number of well classified boys' name was increasing, the one for the girl's name was decreasing. And that's where now we went to some social interpretation. We can see, for instance, in this picture that is attached, some words. Mohammed made it understandable and made it clear, explained that those words together are mainly showing some bias. So it is mainly showing that words like murder, sisters are more related, for instance, to household tasks like to cleaning, feeding, feeding children and everything. Why words like other words like doctor, like scientist, like footballer are more associated to the the male gender, which is something that in our society is very, very, very common. And that's why I was saying those models actually integrated those bias, those different aspects, cultural aspects, and daily life aspects of the language that are spoken. Many research actually have shown that those word embeddings really integrate the, let me say, since they are trained on data that have been collected from humans being part of the society. So those data actually also represent the social aspect, social, let me say, um, let me call it the social aspect of those languages. And there have been tremendous works about it, about debiasing what embedding models to make prediction much more fair. So we know, for instance, debiasing models or method, hard debiasing or double debiasing and everything. So we came to the conclusion that we need to apply those techniques. We tried also to apply them by just reducing the length of the target word toward of the word that we are trying to predict toward the target word. So we reduce the minimum length using those properties that has been shown in the formula of the Poincare word embedding models. But it is something that we need much more to work on. And we believe that this is another pathway to go through. So, as future work, we want to keep going to collect more data and to leave this research, these ideas on a very much more bigger scale. And at the same time, make sure that we focus also on the linguistic aspect. Why did both models perform and were able to recognize very well, let me say, boy names and not girl names? So that was everything. I thank you for your time, for your contribution, for your presence here. I hope you enjoy something. And it was a very glad, it was a very big pleasure for me to present you this work. If you have any question, we released the code source and the pre-trained models, albeit they are very small, on our GitHubs, so that we can promote um, reproducibility. So people can use what we've done and improve it, create on a bigger, larger scale word embedding models that could be used for downstream tasks. We also set standardization and guidelines for creating those word embedding models on African languages and show that using one language, we can efficiently capture similarity, meaning representation on a complete different language. So that was me. Thank you for your time. Thank you for your attention, and bye.